started. The math party, fun times. All right, so let's go ahead and bring this up. I didn't have time to pull up your. All right, let's see. We are on domain and range. If you understood Friday's lesson, this one shouldn't be so bad. If you really struggled with Friday's lesson, you're going to have to kind of catch up quick. So we're talking about the domain and range of everything else we've done. So domain of an equation tells you what restrictions there are on your x variable. Your domain is always, always, always all real numbers, unless you have a variable in the denominator or under a square root. Now I'm going to add to that real quick. Maybe you want to write this down, maybe you just want to watch. But in the denominator, so if I ever have anything like this, if I have a function and I have 1 over x, or if I have a function and I have like 1 over x minus 2, or I have something like this, x plus 3 over 2x minus 5. There's always going to be restriction if the variable is in the denominator. Why? Because what value can you never have in the denominator? Anyone? What can a denominator never, ever, ever be?
0.
Exactly. So your denominator can never be 0. So your denominator can never be 0. So that's what sets some of those restrictions. Now, again, it can't equal 0, but it could be positive, it could be negative, it can't be 0. So we'll talk about this. There's something else if it's under a square root. So if I have something like x under a square root, or I have something like x minus 2, what can you not have to be a real number? What can you not ever have under a radical?
Negative.
Exactly. So they cannot be negative. If it's under radical, the entire value here cannot be negative. It doesn't mean x can't be negative, because if I had something like x plus 3, then that means this whole thing has to be greater than or equal to 0. And that's it. So we're going to take a look at what the domain could be. Now, I talked about the range, but we really don't get into the range very much. It gets too complex. But with the domain, absolutely, you need to understand that. What are your restrictions on what x can and cannot be? So let's move on here. Let's talk about this. So I want you to graph it and tell me the domain. Well, first of all, you have to understand what the parent function looks like. You have graphing calculators. You can type this in the graphing calculator. What do you think my vertex is for this?
0, 0.
Not 0, 0, because what's happening to your x? You're doing what?
Negative 3, 0.
There you go. So your vertex is negative 3, 0. If you understand what we did on Friday, then this lesson should be pretty quick. My vertex is negative 3, 0. Now my parent function, if I go to my next number right next to it, I know that all of my x values, when x is negative 3, it makes this whole thing equal 0. Can x be negative 4? So can I have this negative 4 plus 3? Yes or no?
No.
No, because that would give me a negative under the radical. So as soon as I see a radical, I always need to think whatever's here has to be set greater than or equal to 0. So my domain is real simple. My domain is all real numbers subtract 3, where x is greater than or equal to -3, but how in the world do I write that in interval notation? So my x, it's gonna look something like this. How do I write that in interval notation? What's the furthest left it's gonna be?
Say closed bracket, -3, then positive infinity.
That's exactly right, with a parenthesis. So your domain is going to be a closed bracket because it hits -3. Remember, I'm talking about left to right. So the smallest it will ever be is -3, and it goes on to infinity. Now we can go ahead and talk about our range. So I said we're going to talk about it, but I'm not going to actually assess you on this part. But what's your range here? What's the lowest value it ever gets? Again, lowest, now I'm looking here. So what's the lowest value it ever gets to?
-3.
Now, so you're looking left. Now I'm from right here, I'm looking up. So what's the lowest value it gets to? 0. And how high is it going to go? To positive infinity, because it's going to keep going up. Now today we're going to keep discussing the range, but we're not going to focus on it. The domain is what I really want you guys to have down for right now. Remember, your domain is left to right, your range is low to high. And I completely understand that this is confusing. I want you to understand how it's being shifted and what that means for the domain. So let's do the next one. Because a square root cannot be negative, you take whatever is underneath the radical and you always set it greater than or equal to 0. Now this is for the parent function. So if I moved it like the -3, then this value just changes to +3. So you cannot have a real number under a radical that is negative. It can be imaginary, but not real. Again, I know some of you guys write this down, but we've already kind of pre-taught this, discussed it. I'm going to move on here in about 15 seconds just for those that write this down. All right. So again, if I'm asking what your domain is here and what your range is, let's start with the domain. What value do I have under the radical? And you can just read off the entire thing. What's under the radical? -42. So whatever's here, no matter whatever is there, you set it greater than or equal to 0. So any questions about that? Again, why do I set it greater than or equal to 0? What can you not have under a radical?
Negative.
So that's why it has to be greater than or equal to 0. So now you solve it. So 6x is greater than or equal to 42. So x has to be greater than or equal to 7. So how do I write that? Again, x is greater than or equal to 7. How do I write that as interval notation? First of all, is it a bracket or is it a parenthesis?
A bracket?
Why is it a bracket?
Because it's a number.
Because it's or equal to. The or equal to is what makes it a bracket. So it has to be greater than or equal to 7. So bracket 7. If I want everything bigger than that, it goes to positive infinity. Now with the range, again, I want to just draw attention to this, even though I'm not going to assess it. I'm not adding or subtracting anything here. That is your K value. In other words, no matter where this is, I know that it's going to be somewhere on here, in this case right here, and it's going to open up. So my range is going to be, is it greater than or equal to 0 or less than or equal to 0? From low to high, and I know it's a Monday, but come on, people. This is going to be a boring class. I'm just talking the whole time. So it has to be greater than or equal to 0. So the lowest it will be is 0, and again, it goes to positive infinity, from low to high to positive infinity. Any questions? Now, one thing that people make mistakes on, and I can't remember if I put it in the slide or not, is here we go. If I have something like this, f of x equals, and I gave you something like x plus 2 plus 3. You guys should know that your vertex is at -2, positive 3. That's your vertex. So it's been shifted left 2 and up 3. Well, my domain is whatever. This doesn't affect my domain. This is going to be with my domain. This affects my range, and that's it. All right, so let's see the next one. Oh, I took it off. Now, this is something else that we talked about in the very first slide. If we have an x in the denominator, x can be absolutely anything. It can be positive, it can be negative, it can be a fraction, it can be anything except for 0. Because you can't divide by 0. Your domain in every situation. Now there are some other parts that come up, not this year, but there are some other things that come up that might restrict the domain. But all that you guys have to worry about is it under a radical or is it in the denominator? For instance, logarithms those aren't all real numbers either, but we'll discuss that later. So again, whatever's in the denominator is what I would set equal to 0 because it cannot be that number. Now, let's do this real quick. If I said I have a function that looks like this, and I'm kind of pre-teaching this before we truly get into it, but all you have to do, I do not care about whatever's up here. I don't care about the top at all because your numerator can be 0. Your denominator can't. So all I have to do is take the denominator, and this time I want to set it equal to 0. So x equals 2. This is the value that makes the denominator equal 0. So everything, every x is fair game except for 2. So how I would write that is everything to the left of 2 until 2 with a union of 2 to everything to the right of it. And basically this means everything except for 2. Any questions?
So rational expressions will always have the u?
Yes, because now I'm saying it's not just it goes from here forever. It's what this would look like is something like this. So 1 over x, x can't be 0. So if x can't be 0, let's do this real quick. So if we forget what this looks like, make a table. So if x is -2, then your y value would be -1/2. If x is -1, your y value is -1. X is 0, undefined. X is 1, I get +1. X is 2, I get 1/2. So let's see, when x is -2, y is 1/2. When x is -1, y is 1. So basically, if I said x was 1/2, it's going to look like this. So it's going to get infinitely close to 0, but never touch it. This is going to get infinitely close to +2, but never touch it. And that's what that means. Now, you don't necessarily have to worry about the graph, and I'll show you why here in just a minute, because you have your graphing calculators, and I'll show you how to do that in just a second. So find the domain of the rational function. Again, do I care about what's on top at all?
No.
No, not even a little bit. So all we do here is I take this and I do what to it? Set it equal to 0. Add 4 to both sides. What this means is x cannot equal 4. So x can be any value except for 4. Notice I'm not asking you to graph this today. But x can be anything except for 4. So how do I write it in interval notation? It can be anything less than 4 until 4, or anything greater than 4. And that's it.
So are you always setting it equal to 0?
Always, if it's in the denominator. Now notice the difference. If it was in a radical, if it was under a radical, then I take whatever's under here and I set it greater than or equal to 0 because it has to be positive. Here, this could be negative, it just can't be 0. So I always set it equal to 0.
Okay, so if it was positive under the radical, would you still have to do that greater than or equal to?
If I have this, yep.
No,
Oh, if it was positive, what do you mean if it was positive? Like what? Give me an example.
if it was just like x plus 4.
Yep, if I had x plus 4 under a radical, it's still going to be greater than or equal to 0 because this value cannot be negative. And that's what this is saying, it can't be negative. This is saying it can't be 0.
Okay, thank you.
Okay, now I'm going to show you this real quick. I'm going to stop sharing. We had 3 over x minus 4. Can you guys see that? So if I go to y equals, and I hit 3 divided by parenthesis x minus 4. Now I want the denominator written as a quantity. I could graph this, and man, that looks kind of ugly. So guess what I do? I hit zoom 6, that's zooming standard, and that's what it looks like. So you don't have to necessarily worry about the graphs of these because you have a graphing calculator.
What are you typing in?
I typed in that equation, so it was 3 divided by the quantity of x minus 4. So whenever you type that in, make sure it's a parenthesis x minus 4, and make sure you don't do 3 divided by x minus 4. They look the same, but your denominator or numerator, it's always a quantity. So if you have more than one thing going on, and I want you to see the difference here. The second one's in red. If it's not in parentheses, then it reads it on the outside as how it's been moved down for. The original one hadn't been moved down for, it's been moved right 4. Big difference, okay? So again, you guys have your calculators, know how to use them. Any questions so far? So let's go back. Oh man, I didn't tell you you'd have to do math in here. So what do you think you do? I know I said it, factor to find the restrictions. How do you do this? Well, how can I factor x squared plus 7x plus 10? You're always going to have to look to factor. How do I do that? What is this factored?
+2 +5.
Perfect. And one thing I kind of want to warn you guys about is we don't have time to go over all of the little things like factoring. We've already done it and done it quite a bit. So if you have questions, let me know. But we are going to work under the assumption that you guys can factor, especially on some of the easy ones, pretty quick. So what values of x, I take both of these quantities and I set them both to 0. So what can x not be?
-2 and -5.
So x cannot be those values. It can be anything except for -2 and -5. Those are the only two values that make the denominator equal 0. So to show you what this means, if -2 and -5, well, we could always, let's just type this in. So let me stop sharing. 1 over x squared plus 7x plus 10. So 1 divided by x squared plus 7x plus 10, parentheses. Oh man, we got a lot of different stuff going on. That's kind of hard to see. But what I want to show you guys on my calculator, and hopefully you guys can see this, x cannot be -2 and it cannot be -5. It can be everything to the left of it, everything in the middle, and everything to the right. You guys see how there's 3 different parts to this. So I see some of you guys shaking your head. Yes, awesome. So because there's 3 different parts, let me go back to share screen. So because there's 3 different parts and it kind of looks like this. I don't like how I've got that. Let me make a little nicer one here. So I've got something that looks like this. Something that looks kind of like this. And something that looks like this. I have 3 different parts. I've got this part, the left side, I've got the middle, and I've got the right side, which means I've got the left side with the union of the middle with the union of the right side. So now you just need to make sense of this. What does that say? I want everything on the left side. So I want from -infinity until the first place that it cannot be. Well, the first place it cannot be is what value is this right here?
-5.
There you go. With the union of, well, it's everything else in between -5 and -2 with the union of what should be in this last one.
Infinity, -2.
-2 to positive infinity. Remember, you have to go from left to right. So -2, it can't be -2. So everything from -2 back to the right. So that's why it's important to actually graph this and know how to do this. You don't have to do it, but it's going to help you. So let's try and do this kind of again without the graphs. So I know that it's going to be restricted here. So when everything to the left of here, everything in the middle here, and everything to the right of this. So all you really have to do is make sense of what this graph looks like and account for everything. And I understand how this is confusing. It's going to take a little bit of practice. Let's move on. Oh boy, we've got two things here. This is when it gets tough, and not tough really, you just have to think about it. Why is this any harder than anything else we've done? Why do you think this one is any more difficult than the first couple that we did?
Because there's a square root and a denominator.
Exactly. We have a square root, so we must account for both. For both the radical and the denominator. So let's do one at a time. Let's do the radical first. So I have x minus 3, it's under a radical, and if it's under a radical, how do I solve it? I set it
Greater than or equal to?
exactly. So the first part says x is greater than or equal to 3. I'm not ready to do my domain yet because it might already be accounted for. Maybe, maybe not. The second thing that we have to account for is this. And what do we do with the denominator? Set it equal to 0, or say it can equal 0. So x cannot equal 11. Now, I was showing you guys the graph before, but I don't really care about the graph. I can do a number line if I want. Let's get rid of our range altogether. Now think about this. I've got 3 and I've got 11. Start with your smaller value. What does this say? X has to be what? Greater than or equal to 3. So it's all values where it is greater than or equal to 3, except x cannot be what? Cannot be 11. Now, hold on. Any questions? So how many different parts of this am I going to need? Well, I've got from 3 to 11, and I have 11 on. So I have this part from 3 to 11 with a union of 11 on. How do I write it from 3 to 11?
Close bracket 3, and then 11.
With a parenthesis, with the union of. Now, so I've got this covered. Now I need from here to here, which is?
11 to positive.
Perfect. So to some extent, we can get rid of our graphs. And we can go back to just doing a number line. Notice I'm not really talking about the range at all. Any questions? All right, so I think we have one last example. No, I took it off. So that's not really your assignment. I added 2 questions to your assignment. So let me show you your assignment real quick. There's going to be a couple graphing. You guys can use your calculators. Again, I'm trying to make sure that you understand what they look like. So if you go to your class resources, Again, your notes for today are right here, unfinished. Here is your assignment. Oh, that says percent. I meant number. I hit the wrong button. So we've got 5, 11, 13, and 15, 4 to graph. And then you have just 4 where you're telling me the domain. Just the domain, not the range. So 4 graphing and 4 domain and range. And I'll show you what I mean, 5, 11, 13, and 15. Number 5, I want these all in one graph, so see what happens.
Mr. Riley, we can't see your screen.
You can't see my screen at all?
We just see page 48, 5, 11. It's on the PowerPoint.
It's still, oh. There we go. Now can you see it?
Yes.
Okay. So yeah, I'll bring you back to that page. In fact, let's go back to it right now. So if you go to class resources, here's your notes, uncompleted, but here's your notes for today. Here's your assignment. So 5, 11, 13, 15, and 83 through 86. So you have 8 questions tonight, but what that looks like is this. Number 5, that graph is all on one. 11, you've got some quadratics. You can use your calculator if you want to. I just want to make sure that you guys can do this. 13 is absolute values. By the way, some of you guys don't know how to do absolute values. I'm going to show you here in 1 second. And 15 are radicals. The only reason I'm doing this is so you guys are familiar with what it should look like. Then the last part is 83, 84, 85, and 86. So those 4 are where you find the domain, and that's it. No range, just the domain. Let's go back up to this real quick. The absolute values on number 13. How do you do an absolute value? Oh boy. Let me pin my video. I'm doing an absolute value, y equals. There it is. So y equals, and then I hit NUM, or math. So let me do this again. So second quick. If we're trying to graph this, y equals, and I want an absolute value, I hit the math button, and then I go over to NUM, and that ABS is how I put the absolute value in. So if I'm trying to do x, I would just put an x in here. If I'm trying to do x minus 1, I do minus 1. If I'm trying to put something on the outside, make sure you hit over, like plus 2, then you can graph it.
Wait, how do
So,
you put in the lines?
So how do I do what? Say that again. Oh, how do I put in the absolute values? So go to y equals. Then I want you to hit the math button. And then you go over to where it says NUM, so just press over. And then that ABS means absolute value. So basically, the whole reason I gave you this is know how to use your calculator. So then you just type it in, but make sure this stays in the absolute value until you press the over button, and now it would move it like, so if I went minus 3, now it'd be left 2 and down 3.
so if mine shows me ABS and then it has a parentheses, do I just put in the parentheses?
Yeah, so let me use my old one real quick. So your old one does the same thing. So if I do y equals, and I hit math, NUM, I still have the ABS, but now it says ABS parentheses. That means what's in the absolute value. So I could still do like x, and what I say, plus 2, parenthesis, and then minus 3. We'll get the same graph. Oh man, that's ugly. So what do? Zoom 6 to get back to my standard graphing form. So your calculator works exactly the same as both. I didn't need to go and spend an extra $120 for that new calculator. This one works just fine. But what I've noticed is most people have a newer one now, and I want to show you guys on the technology that you have. So I actually have both calculators here next to me. All right, so class is about to end in about 4 minutes. Does anybody else have any questions? All right, this Friday.
Are we still going over this homework tomorrow?
Yeah, I will go over the homework. Instead of having a homework check, I'm going to have a homework quiz where it is going to be, again, about 6 problems that are exactly like your homework, but not straight off of your homework, just making sure that you get it. So you're not going to have to worry about what's there, but if you don't do your homework, you're not going to get it right. So for instance, I would change something like this up here to like -2 + 3. So do your homework or you won't do well on that quiz. You won't know what to ask. And I am going to take literally 6 problems and I'm going to change a number on it. So make sure you guys bring your questions tomorrow. All right, I'm going to stop recording.